Okay, let's do some integral work today. Who can tell me the antiderivative of e to the x? Good. Who can tell me the antiderivative of 1 over x? Natural log of x, that's what we're practicing. Look at letter G here. You can notice that these antiderivatives, they definitely involve substitution. Can anybody guess what u is going to be in this situation? It's a little bit tougher. Yeah. And if you have trouble seeing this, I'm going to rewrite this. You don't have to be able to do this, but I'm going to rewrite it as the integral of 3 e to the, isn't that x to the negative fourth? Isn't that what 1 over x to the fourth is? And then if x to the fifth is in the bottom, isn't that times x to the negative fifth dx? Is that what we have? And I would say that's something I've learned over the years. Tends to still be challenging for calc students. Mr. Luther was in here yesterday. He had to turn up the volume. He doesn't have a very loud voice. He's gone today. He skipped. Skipper. He's not feeling good. All right. So let's take your u is equal to x to the negative fourth. Good. So that means du is equal to what? Negative 4 to negative 5 dx. So for everybody who is asking, how do you know when to use substitution and stuff like that, or how do you know what u is? That's our indication that our choice was correct. See how du gives us the x to the negative fifth? That means we made the correct choice. There's no way of knowing ahead of time. You have to make a choice and see if it comes up with something that you need to cover. That's all you can do. Okay? So I don't have the negative 4, I have a 3. So I'm going to divide by negative 4, and I'm going to multiply by 3. I get negative 3/4 du is equal to what? 3x to the negative fifth dx. Okay? So I've got negative 3/4 du, and that allows me to get rid of the 3, the x to the negative fifth, and the dx. What remains? E to the u. All right? All right. So now the integral becomes extremely simple. We've got negative 3/4 e to the, and my u value is 1 over x to the fourth plus a constant. Yo, you got it. Oh, it's right on the table. Questions?
Wait, it's x to the 4? Oh.
Yeah.
At the bottom.
Yes, but I don't necessarily really care, but customarily we always say you can never leave a negative exponent, right? So some people might say, why don't they write this from the beginning? In mathematics and the language, the accepted practice is to never leave a negative exponent. So you will not see a negative exponent, I believe, on the AP exam. Okay? All right. In this situation here, what do you want u to be? Yeah, so let's just take a thought. Don't write this down, but suppose u is 4x, then du is equal to 4 dx, right? And you can see that that doesn't really help us, does it? Because you don't end up getting rid of the natural log. So let's switch that around, and let's go ahead and say that instead of u being 4x, let's have u equal to natural log of x. What's the derivative natural log? 1 over x dx. So do you have an x in the denominator? Yeah, you do. You actually have a 4x in the denominator, so what are you going to multiply by? 1/4. So 1/4 du is equal to 1 over 4x dx. All right, so I've got 1/4 Integral du, what do I get rid of? Yep, 4x in the denominator dx, and instead of natural log I have u squared. What's the antiderivative of u squared? U cubed over 3, so this is going to be u cubed over 12. Or natural log of x cubed over 12 plus constant. What's different is that we technically have not really introduced the idea of taking an antiderivative of an exponential or a logarithm. I've thrown in probably 1 or 2 practice problems in previous sets just to prime your brain. But in order for us to do with slope fields and separable equations, which is coming up, we have to be more familiar with this. It's different. What's different about letter I compared to what we've seen? Yeah, it's polynomial divided by a polynomial, right? Any ideas on how we might deal with this? Let's just divide by x. Notice how you could rewrite this to be what? Which is 3x plus 4. Have I done any calculus? No. And yet that's a limitation. People will be like, well, I don't know what to do. Well, try rewriting it. Now I'm just, Morgan, what does that symbol mean? Antiderivative. So what's the antiderivative of 3x? That was easy. Plus 4x minus 2 natural log of x, right? What's the antiderivative of 1 over x? Natural log has to be positive. Morgan? We good?
You just wrote it different?
Well, you asked how do we get 2 natural log, right?
Yeah.
And I said, what's the antiderivative of 1 over x? And you said natural log. So the antiderivative of 2 over x is 2 natural log of x.
Okay.
Are we okay?
Yeah.
So when you look at the original form, people are like, well, it doesn't look like the other problems we've done. But do you see when I take the antiderivative, I come up with a natural log? So what's different about letter J? There's 2 terms in the denominator, right? So there's multiple ways of dealing with this situation. I'm going to show you again. Let's just divide it and rewrite it. Do you remember how to divide x plus 1 divided by x minus 1? Well, we just divide. You know how to divide. That was 5th grade, right? X times what is x? 1. Multiply back through. 1 times x is x. 1 times negative 1 is, and I subtract. What's x minus x? 0. What's 1 minus negative 1? 2. So we have a remainder of 2, correct? Do you remember how you write the remainder? It's 1 plus 2 over x minus 1. Have I done any calculus? No, I divided it. And I'm going to use that division in order to now find the integral. Antiderivative of that dx. The same problem as what I had. If that looks familiar to you last year, it's because we graphed rational functions by doing that division process. And we learned how to divide polynomials last year as well, though we did it at a distance. Antiderivative of x, antiderivative of 1 is x plus good. 2 natural log of x minus 1. I want a quick talk about what Kenzie did right there, so we don't make the mistake. Can I show you what she did? So if you say 2 over x minus 1, and you're going to find that integral, if you say that u is equal to x minus 1, then what is du? Just 1 dx, right? So whenever you get du is the same as dx, you could just do that just like normal. It's no big deal, right? If you want to see the process through, trust me, you're going to come out with exactly that. Now, suppose that there was a 4 in there. Then what would du be? 4 dx, right? And that would be a problem then, wouldn't it? So you'd have to multiply by a fourth, so on and so forth. But that ends up working out quite nicely. That's the antiderivative. Nice and easy. Okay, we got 2 left. What do you want u to be in this situation? Sine or 3 plus cosine? Talk to a friend, decide which one it should be, go. Okay, as we glance up here, you can see that the derivative of sine is cosine, and the derivative of cosine is negative sine. So you can see it kind of works out either way, doesn't it? But what's important here is if you take the derivative of sine, do you come up with 3 plus cosine? No. If you take the derivative of 3 plus cosine, what do you come up with? Negative sine. So that's why we want u to be, in this situation, 3 plus cosine of x. Because du, when you take the derivative, you come up with that negative sine of x dx. So what do I need to do now? Yeah, divide by negative, so you get negative du is equal to sine of x dx. Do we now have the appropriate substitution? Yeah, you sure do. So we're going to substitute and say negative integral du one over u. What is the antiderivative of 1 over u? Natural log. So you've got negative natural log of 3 plus cosine. If you put absolute values, it's absolutely fine. I didn't put absolute values. Why didn't I need to? 3 plus cosine is never going to be negative, is it? No. So just understand that if the expression is always going to be positive, it doesn't require absolute value signs anymore. You can. I won't mark it wrong. I'm just trying to help you interpret what you might see on the AP exam. We all good? No. Unfortunately, so to get to your question, in a free response section, if you had 9 out of 9 points and you were working on something, and suppose that the answer was negative natural log of x plus 5, and you wrote negative natural log of x plus 5, is it possible to plug in a value for x and come up with a negative? Yeah, so therefore you have to use absolute value. In that situation, you would receive 8 out of 9 or 7 out of 9, depending on how they did the scoring of the problem. So, you know, if you're getting 7 out of 9, you're doing pretty good anyway. Like national average is usually like 3 or 4 on a problem. So if you're getting 7, you're doing pretty good. So yeah, you'll get 7, 8, or 9 on every one. I've never gone through a free response section and gotten them all right. I've gotten so it's 54 points. So 6 out of 9. So it's 54 points. So I've gotten 53 a couple times. Because I do them every year. As soon as they release them, I go through and do them. They're hard. Like, they're not easy. And at first, like, when I was getting like 50 out of 54, I was like, oh shoot, I don't know if I'm qualified for this course. But I talked to other teachers like, oh, you're doing. I usually only get 45. I'm like, oh, all right, yeah. You know. And I've done all the multiple choice tests. They just released a new one. I was going to do it over spring break, but I didn't feel good. But it's so exciting when they release a new one because I'm like, how will I do? And out of the 45 questions, the worst I've done, I've got a 40 out of 45, but I've gotten 44 once. I got a 44. I missed one problem. So my goal is to perfectly ace it sometime, but I haven't been able to do it. So
Yeah, me too.
that's the goal.
You're going to put my name on.
But so here's the, do you want to know the mistakes I make sometimes? You know, like when you set up your integrals, like you did like f of x minus g of x dx. Remember, you're setting that stuff up. But remember, sometimes you have to put like a pi out front. Like I'll forget to put the pi out front. Like like I did that. No way. But every once in a while, I'll get a problem. Like I legitimately, I did not know how to do that. You know, I just got to take a loss. And then you see, like they do the scoring breakdown later on. And it's like, what percent of kids got that problem right? And it's like 1 out of 50 kids got it right. When if there's 5 options to guess, it should be like 20% of kids are getting it right, right? So if you know only 1 out of 50, you know it's a really bad problem. You know what I mean? So some problems they put out as like field problems. Like they see how they work, and then they change it from there. All right, last example. Yeah, it's totally cool. Like, you're taking such a tough test. You should be so proud of yourselves. All right, last example. What's u? Yep, root of x minus 2. That is what u is. What is du? One over 2 roots of x dx. Looks like I'm on the right track. I like it. I've got a dx here. I've got a root of x in the denominator, but I got a 4. Here I just got a 2. Half. I like the way you think. Sweet. Some of you guys don't like when I do this. You're going to have to live with it, sorry. I always write it down, 1/2 du. And then I cross things off. It helps me organize my work. I struggle with organization. This is something that helps me. E to the u. And doesn't that just make you happy when you write that? Because you're like, oh yeah, I know the antiderivative of e to the u. And remember when you first learned about e, you're like, oh, I don't like e. I don't like natural log. Really? You don't like it? I think it's pretty cool. Sweet. I like it. Yep, remember put the plus here. I might get wrong. I smile.
Wait, if you don't put the plus on the test, they count the whole thing.
I will take a 1/2 point off. They will take, so plus C on the test. If it was worth 9 out of 9 on a free response, you would get 8 out of 9. They would take a point off for getting the plus C. Yep. You ready? All right, finish up that assignment. Tomorrow we move on to slope fields. I'll post the answer key, and I'm going to start posting some videos.